Welcome, Math 107 students, to the preview exercises for Lesson 1, which covers some of the material located in the prerequisite chapter of our book. Much of this material deals with some earlier skills and ideas that you've learned in algebra, dealing with exponents, radicals, binomial multiplication, factoring, adding like terms, etc. So let's take a look at these first 8 exercises. I'll give you a few minutes here to look at the answers that I've put in the second column, and then we'll discuss them. Let's recall that when we deal with exponents, we're trying to keep track of the number of factors that we have, because an exponent keeps track of the number of factors. So in this first situation, we have 3 factors of x, and we're multiplying it by 4 factors of x, which is going to give us 3 plus 4, or 7 factors of x. It's common for some students to forget some of the properties of exponents and to do whatever the operation is here to the exponents. But recall again, if you happen to forget what the exponent rules are, you can just remember what it means to cube x and to raise it to the 4th power, and you can see here you have 7 factors of x. The second problem is true. We can take this particular fraction, and since everything is multiplication, we could create 3 separate multiplication problems here. The first division problem here is 24 divided by -2, which is -12. That's right here. X squared divided by x to the 5th. If you recall, when you divide with the same bases, you subtract your exponents. That gives you x to the -3, which says x to the 3rd changes its position from being in the numerator, as it is here, into the denominator. And that's where it's located. And again, y to the 13th divided by y to the -2. As long as your base is the same, you keep your base, you subtract your exponents, and you get y to the 13 plus 2, which is y to the 15th. So that is a true statement. The next problem deals with adding, and no matter what you add or subtract in mathematics, things have got to be like. Whether we're adding numbers, subtracting numbers, we line up the ones, the tens, the hundreds, etc. If we're adding and subtracting fractions, the denominators have to be like. In this particular case, we're adding 2 terms. Anytime you have an addition or subtraction problem, the pieces of an addition and subtraction problem are called terms. So this is your first term. This is your second term. So since both of these terms are dealing with the same like thing, that is the radical 2, we simply add the numbers in front of them, which are called the coefficients. So we have 21 of these things called radical 2 and 10 more of these things called radical 2. That gives us 31 radical 2's. We don't multiply the radical 2 times each other. There's no multiplication between them. It's simply adding. So your answer here is 31 square roots of 2. Now number 4 is a big concept for you to clearly straighten out in your mind, the difference between something like this and something like this. In this problem here, we're dealing with exponent properties because everything you see inside the parentheses involves multiplication. Similarly, if everything you saw inside the parentheses was division, you can apply your exponent properties in each of these cases. However, in this particular example, you are squaring a binomial. This is what we call a binomial. It's 2 terms. It's a quantity or an algebraic expression separated by addition or subtraction. Your only choice here is to simply take that base and multiply it by itself. So you show that you have two factors of that base, and now you use your distributive property twice. So you get 16x to the fourth minus 4x squared minus 4x squared plus 1. We get to combine these second and third terms here. We get 16x to the fourth minus 8x squared plus 1. So this is often a time when students can get very confused and they try to just apply the exponent rules here. Again, remember, unless you see multiplication or division, the exponent properties do not apply. The next one is true. Let me erase the answer from the previous one. Here we have addition. So you separate your terms, and then you're subtracting a term. Before we can perform this addition and subtraction, we want to simplify this term with our exponent property. So that's x to the fourth. So now we have x squared plus x squared. Those are like, we have two of them. So that gives us 2x squared, take away x to the fourth. And that's as simple as we can get because these are now unlike terms. Number 6 takes us back to our radical properties with radicals. Often we start this way with the radical and we end up separating that radical into a multiplication problem where hopefully one of our factors is a perfect square. This problem starts with the factors already written for you, and they're not very helpful. I mean, we could work this problem as it is and still come up with 10 square roots of 3, but it's going to take us a little while to get there. So when you see a problem like this, you want to multiply the 50 times the 6, put it under one radical, in this case the square root, and then start all over again as I did here with the square root of 100 times the square root of 3. The square root of 100 is 10, so your answer is 10 times the square root of 3. Problem number 7 is a subtraction problem. You have two terms here. And in the first term, you can drop these parentheses since there's nothing outside of these parentheses except for the number 1 right here. So we can just drop the parentheses. However, in the second term, we have to subtract each one of the pieces inside the parentheses. And often students will remember to subtract the 4x, but it's this term right here. When you subtract a negative 7, remember that becomes a plus 7. So this simplifies to 3x plus 5, take away 4x plus 7, which when we combine like terms, we get negative 1x plus 12. So that's false. Again, the error happens with this second term right there, the plus 7. Number 8 is a multiplication problem. Again, we call this a binomial times a binomial. So this would be like multiplying a 2-digit number by a 2-digit number. You have to do 4 separate multiplications. So similarly here, if we do it horizontally, we have 4x times 2x, which gives us 8x squared. We have 4x times negative 3, which gives us negative 12x. So we've used our distributive property. We use our distributive property once, but we've got to use it again in order to distribute the 1 times the 2x, which is positive 2x. Notice I'm lining these two terms up since they are like, and then the 1 times the negative 3. So now I add 8x squared minus 10x minus 3. So that is a true statement. Some of you may have learned that the technique for, or the acronym given for a multiplication of one binomial times another is FOIL. We tend to use the mathematical terms here, which is the distributive property twice, but that's essentially what many of you may have picked up earlier in another algebra class. I also want to show you that if you're not comfortable multiplying these things horizontally, you could set it up just like you do a two-digit number times a two-digit number. -3 times +1 is -3. -3 times 4x is 12x. Notice our multiplication always tells us to then move in one place to the left because now you're dealing with a different place. 2x times 1, this is a -12x, sorry. 2x times 1 is 2x, and then 2x times 8x is 8x squared. Now you get 8x squared minus 10x minus 3. Okay, so those are the preview activities for lesson 1. Hopefully something that may have not been clear to you or that you've forgotten has been cleared up.